All right, this is lesson 7.1, Arithmetic and Geometric Sequences. At the beginning of chapter 7, we will be working on unit 12 in Khan Academy, which is about sequences. We'll cover these 4 skills, and after we touch on those skills, the rest of chapter 7 will actually be in not in unit 12, but rather unit 14, which is about exponential growth and decay. But let's talk about sequences for today. Your objective for this lesson is that you'll be able to extend arithmetic and geometric sequences when either given the first few terms or the formula. Okay, so before we talk about arithmetic or geometric, you should know what a sequence is. And all a sequence is a list. It's a list of usually numbers. And a sequence is arithmetic if to get from each term to the next, you're going to add or subtract the same number. Add or subtract what we call a common difference. And we're going to call that common difference D. So we've played the what's the function game a lot by this time in the semester. So if you think about that what's the function game, remember you give me inputs and I will tell you outputs. And hopefully you remember the strategy of picking inputs that are equally spaced, let's say 0, 1, 2, and 3. And I hope that you remember from class that whatever I tell you for these outputs, I'm just going to put dots for now, but I would tell you numbers. If you notice that to get from each output to the next, they jump by the same amount, that you're adding or subtracting the same thing, we could call it D for common difference, then you know that function is linear, and that's exactly what we have here. So A1, this is actually written A with a subscript of 1, so when you read this out loud, we're going to call this A sub 1, A sub for subscript, and this would be A sub 2, and so on. All we're doing is A1 is just the first term. To get to the next term, the second term, you take the first term and you add that common difference. To get to the third term, well, you know what the second term, or you could actually take that first term and add 2 common differences. Or to get to the fourth term, you would add 3 common differences, and so on. But we're adding that same common difference from each term to the next. So we have a rule here. This is important. I would recommend you put this on a note card. This is the explicit, there's an L in there, explicit formula for an arithmetic sequence. The nth term, that's N with a TH, really that's just like in place of like first, second, third. I don't want to tell you exactly what number. This is just the nth term of an arithmetic sequence where the first term is A sub 1 and the common difference is D, is given by this explicit formula. We take our first term and we're going to add the common difference n minus 1 times. Notice like for the 5th term, we added 4 common differences. Or to find the 4th term, we took the first term and added 3 common differences, 1 less than 4, or 2 is 1 less than 3. That's where that comes from. All right. So let's get right to the practice problems. Are the following arithmetic sequences? And really, I'm just giving you a sequence, and you can say, yes, it's arithmetic, as long as it has a common difference. So let's just check. To get from 3 to 8, I am adding 5, right? To get from 8 to 13, I'm also adding 5. To get from 13 to 18, I'm adding 5 again. This 5 is showing up a lot. It's common to whatever terms I pick in the, whatever consecutive terms I pick in the sequence. I'm adding 5 every single time. There is a common difference, so we can say yes, the sequence is arithmetic because the common difference is 5. All right, let's try number 2. We start with negative. I'm going to use a different color because I wrote some stuff in blue already. To get from, here, let's just go this way. To get from -2 to -12, this is the only time I'm going to write it this way, but I'll write -10. You can think of it as subtracting if you really want to. And sure enough, from -12 to -22, we're subtracting 10 again and again. So yes, this is arithmetic because the common difference, D, is -10. Even though, yes, you could say you're subtracting from one term to the next, I want you to start thinking of this as adding the common difference as you go from term to term. So we're really adding -10 to get to the next term. But it is definitely arithmetic. All right, now that you have the hang of it, try numbers 3 and 4 on your own. Pause the video and come back and check your work. Okay, so for number 3, there is no common difference. We're adding something different each time. The common difference does not stay the same. So that word common, it means that it stays the same when you add each time. It's not. As a side note, there is a different pattern here, but we're not adding the same thing every time. We're multiplying, and we'll actually get to that later on in the video. But for right now, we'll just say it's not an arithmetic sequence. Number 4, it is arithmetic. The common difference is 0.5. We're adding 0.5 from term to term. Okay. This next set of practice problems tell us to write the rule for the nth term of the sequence. So we have a sequence here, and remember, we need to write something like this, the explicit rule, the explicit formula. So we need to know the first term, a sub 1, and we need to know D. If we know that, then we're good. Well, it shouldn't be too hard to find the first term. It's just the first number in our list. This is a sub 1. It's 3. And then, to get from one term to the next, let's just double check and, oh wait, this is the same sequence as we had in number 1 up there, right? So we're just adding 5 every time. So the common difference is 5. And we're going to throw all of that together into our rule. A sub 1 should be, A sub n should equal a sub 1 plus the common difference times n minus 1. And we're just going to plug in what we know. A sub 1 is 3. And the common difference is 5. There we go. That is our rule for the given sequence. Let's try number 2. We, again, can pick out that first term right away. And this is the second one again, so we're adding -10. Really, you could write it as -10, that's fine. So our common difference is -10. And we're going to take our rule, a sub n equals a sub 1, which is -2, plus our common difference. I'll put it in parentheses because there's a negative in front of it, times n minus 1. Now, if you really want to, I don't mind, you can write it either way. As long as you're comfortable with your minus signs, you can just put -10 times n minus 1 there. That's still correct. I'm going to write it like that, though. All right. I apologize in advance, but there are some printing errors on this lesson. So anything in pink is what I want you to correct on your paper. The directions should say that we're finding the fourth term of the sequence. And this might look a little strange to you. Number 1 and 3 aren't explicit rules. 2 and 4 are explicit rules. We can pick out our first term and our common difference. First term, common difference. Oops. But 1 and 3 have this a sub n minus 1. And so these are actually what we call recursive rules. You might see this in Khan Academy, and that's why I have included it in this lesson. For the most part, we're just going to work with the explicit rule in this class, but you should be familiar with what a sub n minus 1 means. Our recursive rule relates the nth term, which is just a sub n, to the term before it, a sub n minus 1. So this is saying in number 1, it's telling us the first term, it's 16, and it's just saying every term is equal to the term before it plus 5. So we already have a sub 1 plus 5 is going to be our common difference because every term is just the term before it plus 5. That's what our common difference is. So to put it all together, we're going to use that rule, a sub n. We're going to write our explicit rule, I guess. A sub n equals our first term, which is 16, plus our common difference times n minus 1. But we're asking now for the fourth term. So we're going to write a sub, I'll use a different color, 4 equals, it's the same rule, I'm copying everything in blue down again, except for n, because now I know n needs to be 4. I'm looking for the fourth term. Now it's all numbers. I can tell you what 16 plus 5 times the quantity 4 minus 1 is. I would do parentheses first, 16 plus 5 times 3, and then between addition and multiplication would come next, right? So that's going to be 16 plus 5 times 3 is 15, and we can add those, we'll get 31. So 31 is our fourth term. All right, let's try number 2, because number 2 is not written recursively. It's our regular explicit rule that we like. So let's try that one. If we want to find the fourth term, a sub 4, I'm just going to use the rule that was given to us. It's going to be the first term, negative 3. And it looks like our common difference is also negative 3. But since we don't want the nth term, we want the fourth term. I'm replacing n with 4. And we can figure out what that is just by using the order of operations. So we'll have negative 3 minus 3 times, another 3. Lots of 3's today. So that's negative 3 minus 3 times 3 is 9. And negative 3 minus 9 is negative 12. So in the sequence for number 2, our fourth term would be negative 12. All right. Just one more time, double check that all the pink stuff I wrote, all these corrections, make sure you wrote those down correctly in your notebook. And then I want you to try problem 3 and 4 on your own, and then come back and check your work. Okay, so number 3, we pick out our first term, and since every term is the term before it minus 10, our common difference is negative 10. Sorry about that. Here, let me just erase this. There we go. So you should be able to write the explicit rule, just like we did in number 1. If you really want to, this plus negative 10 thing, you can just write minus 10. However you want to write it. But eventually we're going to move from this explicit rule with n, and we'll replace n with 4. After that, order of operations, and we should end up with the fourth term being negative 24. Number 4 is written explicitly already. If you plug in 4 for n and follow the order of operations, you should find that the fourth term is 1. All right, that's it for arithmetic sequences. Second part of our notes on page 33 is about geometric sequences. They're very similar because there's something you're doing to get from one term to the next. It's just we're multiplying or dividing from term to term. So again, the pink stuff is the typo. Please fix those. I'll give you a moment to write that down. Pause the video if you need. But the idea is that we have a first term, and to get the second term, we just take the first term and multiply by something. It's a common ratio. We call it R for a ratio. And it'll be geometric if you multiply by that R again to get from the second term to the third term. And so that'd be R times R is R squared. Multiply by another R to get the fourth term, and multiply by another R to get the fifth term. Again, in general, this means that the first term is already there. We're not multiplying by any R's. To get the second term, you multiply by one R. To get the third term, you take the first term and multiply by two R's. And so if you notice that pattern where this is 3 and the third term has 2 common ratios, the fourth term has 3 common ratios, in general, our explicit rule is that we'll take our first term and multiply by R to the n minus 1 power. This is our, I'll write the word again. This is our explicit rule for geometric sequences. Oh, let's rewind a little bit again. This should remind you of exponential functions. Remember, if we're playing the what's the function game, and again, you use that really good strategy of picking inputs that are equally spaced. We'll just use 0, 1, 2, and 3 again. And I give you the outputs. If you notice a pattern where we're multiplying by something, I'll use R since that's what we're using already. If you're multiplying by the same thing to get from one output to the next, that's the common ratio. And really, that's what exponential functions are. And we talked about it a little bit last chapter. Those don't go away. We're going to see that again this chapter. All right, on to the practice problems. I'm asking you to tell me if these sequences are geometric or not. And again, you can say they're geometric if they have a common ratio from one term to the next. So are we multiplying by the same thing from term to term? Well, negative 100 to get to positive 10, you can think of this as dividing by negative 10. And again, we're from positive 10 to negative 1, we're dividing by negative 10 again. And negative 1 divided by negative 10 would be positive 0.1. So yes, we do have a common ratio. This is really the only time I'm going to write it as division. You could have also thought of this as multiplying by negative 1/10. The common ratio, common ratio R is what you're multiplying by, not what you're dividing by. So our common ratio, we'll think of it as multiplying by negative 1/10. All right, let's try number 2 to get, again, I'll just use a different color. To get from 5 to 10, I am multiplying by 2. We're off to a good start. To get from 10 to 15, I'm not multiplying by 2 again. So I can stop there and say this is not a geometric sequence. There is no common ratio. You could write it, you're multiplying by, 1.5, and then multiplying by something else, but it doesn't say the same, so we'll just say no. There isn't a common ratio. Now, we just learned about arithmetic sequences. We know this is actually not multiplying at all. We're adding 5 every time. That's an arithmetic sequence, but this isn't asking that. It's just saying, is it geometric? So, no, it is not. All right, try numbers 3 and 4 on your own and come back and check your work. Number 3, yes, it has a common ratio. We are multiplying by 1/3 each time. And number 4, we are multiplying by something different each time. We're multiplying by 2, and then by 3, and then by 4, and then by 5. That is a pattern, but we don't need to talk about it right now. It's just suffice it to say this is not geometric. There is no common ratio. All right, moving on. Write the rule for the nth term. So we're going to write something like this for numbers 1 and 2 here. Again, we just need to pick out our first term. A1, A sub 1 is 2. And then, since we're multiplying by 2 every single time, our common ratio is 2. So our rule said that A sub n is A sub 1 times r to the n minus 1 power. We are going to write that, but we're just going to include what our first term is. Our first term, I'm going to try to color code it. A sub 1 is 2 times our common ratio is also 2 to the n minus 1 power. And that's our rule. All right, let's try another one. In number 2, our first term is 256. And to get from 256 to 64, you could think of it as dividing, but I told you let's think of it as multiplying instead. We are multiplying by 1/4. Check my math if you don't believe me. You might have thought we're dividing by 4, which is still true, but multiplying by 1/4 is going to save us some time later. And sure enough, we're multiplying by 1/4 again and again to get 16 and 4. So our common ratio is 1/4. So to write our rule, we would say A sub n equals A sub 1 times our common ratio raised to the power of n minus 1. There we go. All right, last part, and then we're done. Find the fourth term. Again, take some time, make the corrections in pink, pause the video if you need. Find the fourth term of the geometric sequence given the rule. We've got 2 recursive rules here. This is just saying, well, really, I wrote it this way. Sometimes they write it like that with, they can write A or B as the sequence. And this is more like function notation, which still works, but we're going to use subscripts instead. So A sub 1 is -8, our first term, and A sub n, or the nth term is just the term before it times 3. So if each term is the term before it times 3, then really what we're saying is that's our first term, and 3 is our common ratio. So the explicit rule would be that A sub n is our first term times our common ratio to the n minus 1 power. And we're going to take that to find A sub 4. It's going to be our first term times 3 to the 4 minus 1 power. Following the order of operations, we would have -8 times 3 to the 3rd power. Exponents come before multiplying, so 3 to the 3rd power. 3 times 3 is 9, times another 3 is 27. And finally, -8 times 27 is going to leave us with 216. Sorry, -216. There we go. Let's try number 2. So again, we have, well, this time it's explicit already, which means A sub 4 is going to be our first term, 5, times -2/3 to the 4 minus 1 power. That's 5 times -2/3 to the 3rd power, which is 5 times Negative 2 times negative 2 times negative 2 is going to be negative 8. And 3 times 3 times 3 is 27. So we can multiply. Remember, that's 5 over 1. So we multiply fractions straight across. And we'll be left with, what is that, negative 40 over 27. All right. Try number 3 and 4 on your own. Come back and check your work, and then we'll be done. Okay, so for number 3, we have our first term. Common difference is a half. So we should end up with the fourth term is 2. Number 4, our fourth term should be negative 12. As always, ask a question or make up a question at the end of this video, and I'll see you all in class.